The academic field of marketing has embraced Bayesian statistics because, for a number of reasons, where other disciplines within business have not. This is really a curious innovation of science into our discipline. Marketing has embraced it because our data sets are shallow. We have wide puddles of low depth. As I think about the data that I collect in any survey, if I think about the data that's collected from the internet or in the cloud on any product category, I have a very small amount of information per respondent. But many, 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 many respondents that I can sample from. I have huge data sets, but they're wide and shallow. They're not deep. Right? So I am lucky to have 24 observations on any object of inference on which to do analysis. After asking about 12 to 16 conjoint questions, people get tired. You just can't ask them any more about that. To find a product category in which you observe people shop in a relatively stable environment for more than 12 times is a rarity. It's not something that's very regular. And so I'm constantly faced with wanting to conduct small sample inference. I want to understand and make probabilistic statements and make predictions on things that have small amounts of data. And therefore, I cannot rely on large sample asymptotics. I cannot rely on the normal distribution. I'm not sure that that exists at such a small level of data. I can't rely on the central limit theorem. I have to deal with all of the uncertainty that's present. And what I want to do is describe the entire posterior distribution of an individual's set of coefficients, and then make predictions on that. And so if I really think about that a little bit, the last thing I want to do is to plug in a point estimate of their mean. I have to take into account their uncertainty, or I'm going to overpredict actions that I might consider. And I move to the simplest method of shoring up the data deficiency. The simplest method of doing that is something called a random effect model. And the random effect model embraces two distinct ideas. It says that no two people are exactly alike. And we all say amen, hallelujah, we agree. And the random effect model also says, and this is where we really get teeth and we get information sharing, no two people are exactly different. No two people being exactly alike means that I do not take your data and my data, stack it on top of each other, and estimate a common parameter for both of us, because as I do that, I'm assuming that we're the same. And no people being exactly different means that I do not take my data and move it over here, and your data and move it over here, and try to estimate a coefficient for Greg and a coefficient for you, and treat us as if we're unrelated to each other. The random effect model is the simplest of models that allow us to say that there is something called a mean, there is something called a dispersion around the mean, there is something called an outlier. The random effect model says that the betas in my regression across the units of analysis, across the market areas, across the key accounts, across the respondents in my survey, come from a distribution. And when it comes from a distribution, there's a mean and there's tail behavior associated with what it is that I measure for each individual. And so knowing that somebody looks like they're atypical, or knowing that somebody looks like they're typical, provides a tremendous amount of information for which I can do my analysis. So that person that never bought Doritos or Fritos may be atypical for that brand because we know an awful lot about the proportion of the population that do buy that at various price points. And then I can use that and move that into my analysis through Bayes' theorem. So the first thing that I want everybody to remember is that Bayes' theorem allows us to not treat respondents in isolation. That it provides a bridge for us to move across respondents and to share that information formally through Bayes' theorem in making predictions. So it shores up this data deficit that we have at the individual level. And the other thing that it does, which has been truly a breakthrough in analysis, is that Bayes' theorem is unique at allowing us to back out individual level coefficients, individual level market or respondent. I don't give up the ability to study each of the units of analysis in my analysis. I can back out my set of part worths in a conjoint. I can back out estimates of your degree of satisfaction with the product. I am pooling the data together while retaining the identity of the individuals. And that's something that's special out of Bayes' theorem. This has created a breakthrough in that these coefficients at the individual level can then be brought into a decision tool and used to explore various marketplace scenarios and to conduct what's known as counterfactual analysis. It allows us to play what-if analysis or what-if games. And you can consider, I'll go back to conjoint. A lot of my research is done in that arena. A conjoint exercise, I measure part worths. I get those for each individual. I put it into a spreadsheet. And then I start to play around with who is going to be most responsive to a feature change. Who would be most likely to switch because of a price cut? Who appears to be most on the fence? And who appears to be most brand loyal? I can start to characterize those people out of my data set and achieve what we ought to have been achieving in marketing in the first place. Analysis in marketing is not about understanding on average what people like. Marketing is not about means. Marketing is about extremes. I am more interested in understanding the upper 50% tail of a distribution than the center of a distribution. If I think about any action that I take and write an economic profit function associated with that action, I would want to take action if the result is above some economic threshold. I am most interested in finding people in the tail of a distribution because that's what an economic profit function would tell me to do. Don't ignore the people at the lower end of the distribution. Concentrate on people at the upper end of the distribution. Extremes doesn't mean the upper 5%. It could mean the upper 25%. It could mean the upper 75%. Bayesian analysis allows me, because I have the individual coefficients, to go into the analysis and figure out who's most affected. Think about what we do when we do market segmentation. Why do we do segmentation? Sure, there's a part about it that involves being concrete and being able to talk about things. There's a part of it, market segmentation, and why we do it, that's about a decision space that's very discrete, and I want to know who's affected by these decisions most. But the most important reason we engage in market segmentation is to explore the extremes of a high-dimensional distribution. We separate the people into groups, we cluster them, and then we profile those groups. And these people reside in tails of a distribution. Marketing has long recognized that it is not about the means, it is about the extremes, but we haven't had tools to act on that until Bayesian statistics came along. So that's why it's one of those breakthroughs. Let's go through an example. This is data from Kraft. It's a fairly old data. It's sales of sliced cheese, American cheese. A very simple model. I have 88 key accounts, 65 weeks of data, intercept, price, and a display coefficient. That's a dummy variable, but you know, a lot of stores don't put Kraft cheese on display very often. Least Squares fails miserably at trying to understand the lift associated with the display in this product category. On the x-axis is the least squares coefficient, plotted on the y-axis against the Bayesian coefficient. The lift associated with a display is estimated to be astronomically high with least squares. And it's because the data are being treated in isolation, and that some of these key accounts just haven't had much display activity. So the key accounts like Albertsons and Kroger and Ralph's and the key accounts across the country. Many of these outliers are absurd. The lift is estimated to be 10 or 12. And then you come over and look at what they are in the Bayesian world, and they're 1 or 1.5. They're much more reasonable. As I said, one of the areas that I do research with is in conjoint analysis. And this provides the second great example that I want to come to. This is a very small conjoint example to teach MBA students about conjoint, where we're looking at Florida theme parks and have a few, a small number of product features, brand name, speed ticket, mobile app, extended hours, and then price. And so I'm thinking about this. I've got 7 theme parks and a part worth for speed ticket, 1 for the mobile app, 1 for the extended hours, and 1 for price. So that's about, 10 coefficients per person. And we can do more than just have a random effect model. The random effect model allows us to pool people together, and we get a lot of action out of that, because this normal distribution has tails, and it brings in outliers, and we get more robust estimates. We can take the betas out of an analysis and relate them to other variables. So for each respondent, I have a vector of coefficients. That's what that beta H is. And I have a rectangular array associated with that, because for each respondent in the survey, I have a set of coefficients. And I can relate that set of coefficients to another set of variables that I'll call N sub H. So H is for the household, N is going to be needs. And we heard in the previous 2 talks from Rob and from Scott, it's about understanding motivation, and I completely agree. I would like to relate beta to a variable that's of interest to me as a marketer. I am not going to put demographics in this and that. We know demographics doesn't work very well for predicting relative brand preference. I want to know, out of this analysis, why somebody would go to Magic Kingdom and not Busch Gardens. I will not tend to get that out of a demographic analysis, because that variable is too broad to explain relative brand preference. So I look at this equation and I go, boy, I would love to get at that rectangle gamma that's in the middle, because if I could estimate gamma, I have a way of mapping needs to wants. The betas are wants. The betas are my part worths. The betas tell me where I'm going to. Maybe I could get a variable that would tell me where I'm coming from. And if I can relate where I'm coming from to where I'm going to, I found the holy grail of marketing. This is a $6 million question. How do we map needs to wants? We solved it by understanding that maybe we ought to be going to a 2-point scale. Just tell me if this need describes you. Just yes or no. Don't tell me how much. Let me avoid this scaling artifact problem. Let's just try to get at a binary indicator variable, whether it's important to you or not. And we measured this mapping within the context of a logit choice model. So I tell you that because if you've worked with a logit choice model, you'll know that a change in a coefficient of magnitude 1, if the beta goes up by 1 in a logit model, that's a big deal. That's at least a 10% shift in the outcome probability. The needs are attempting to be pure and not describing where a person is going to, but understanding where a person is coming from as they consider a vacation in Florida with their family. I have things like I want to go on vacation to relax. I want a wholesome vacation. Or number 6, vacations remind me of my childhood. If a person ticks off the 6 and said, yeah, that describes me, we find that Magic Kingdom rises in its preference on this logit scale by 1.59, which is a lift of about 15 to 20%. It's big. And people are not going to go to Busch Gardens for that. The lift is a minus 1.42, so I'm on line 6 there under BG for Busch Gardens. People just aren't going to Busch Gardens to do that. But the point is that all of a sudden this mapping from needs to wants lights up like a Christmas tree, and the coefficients are large and they're meaningful, and this is the sort of thing you never get out of an analysis of demographics, because demographics would tell you that you'd go to Florida, but it wouldn't tell you what you wanted to accomplish when you got down there. And so we can make movement in measurement. We can make movement in variables that are explanatory, and because of Bayes' theorem. And what we're doing here is similar to the random effect model. I'm relating everybody's betas together. And in a random effect model, I just assume that they come from a distribution. And here, I'm assuming that some sort of a regression model relates the betas. And I can formalize the difference between needs and wants. But this leads to a whole bunch of really interesting things. If you think about your products, you all work for companies. What fraction of a person's life is your product related to? And if you think about that for a second, you'd have to conclude a little narrow sliver of a person's life. Your product, your brand, your offering corresponds to a little piece of the individual. A little piece. So if I'm going to explain how this brand of yours is related to a motivation, I have to operationalize a motivation at the same level. It's got to be a little narrow sliver of a person's life. And then I can think about getting traction. They have to match. Another area is in response styles. We know, as I said earlier, that some people are yay-sayers and some people are naysayers. We use this in customer satisfaction surveys all the time. But there's a real problem in conducting driver analysis on data collected in this way. There are some people that just use the upper part of the scale, and there are some people that just use the lower part of the scale. Some people are happy, some people are grumpy, right? And if there truly is no relationship, and then I overlay your response style on top of that, recognizing that if you answer the first question on the high end, you'll tend to answer the second question on the high end, use the high end of the scale, low and low. What you do is artificially infuse correlation into your analysis. And if you do that question after question, you've got a problem with multicollinearity. Anybody have a problem with multicollinearity? Yeah, it's in spades. Right? So unless you deal with the effect of yay-saying and nay-saying, you're in trouble. And in conducting a driver analysis, I want to move from the X's to the Y's, from the drivers to overall satisfaction, some measure of overall satisfaction. I want people who are forming their opinions. A little bit of this, a little bit of that, and then that made me satisfied. Well, what if people, when they respond to your survey, are going in the opposite direction? What if they halo? What if it's been years since they were at Magic Kingdom, and you're asking them about aspects of the service, and they really don't have a clear, but they know that they had a wonderful vacation. And they said, yeah, that was great. Yeah, it was all great, all great. And the X's are being formed because of the Y. The Y is not being formed because of the X's. There are going to be people in your surveys that are like this. Some people are going to use different parts of the scale. Some people are going to halo instead of form, and you've got to strip those people out of your analysis. Get rid of them. They're not informative for driver analysis. And the way of handling that is to start writing models that are a little more complicated. And say, my probability of of a dependent variable, overall satisfaction, the probability of Y could come from a mixture of explanations. Some people are forming, going from X to Y, and that's the right thing to do. Some people are yay-saying, some people are haloing, and so I can get to the portion of the data that is a good representation of the process that I'm interested in measuring. And this is useful for understanding how people make decisions. And I can do that very easily in Bayesian methods, and it's very hard to deal with that heterogeneity any other way. If I think about the one thing that screams at me when I see marketing data, it is that data is characterized by a whole lot of zeros. In my marketing data sets, especially data sets related to what people do, most people don't do most things, right? And that's represented by a zero. I didn't do that. I didn't go to that website. I didn't read that magazine. I didn't buy that product. I didn't. 0, 0, 0, 0. What predominates in our marketing data sets is the number 0. And that tells me two things. It tells me first that people are goal-directed in their behavior. They're maximizing something subject to constraints, or you would never get that many zeros. people are wandering through life like a random walk on Wall Street, you wouldn't get all those zeros. It speaks, it yells at you when you confront this data. And the thing that we've learned over the last 20 years, which is at odds with our previous speaker, and I can say that because he's no longer here, is that simple economic models work well, very well. Here are 4 questions that I think we all need to ask ourselves. The first one is to do with dealing with high-dimensional data and asking the question whether we ought to be aggregating or filtering. And I think the answer is filtering. The question I put to you is this. Do people, I want you to really answer this in your mind. Do people act for concrete reasons, or do people act for abstractions of reasons? If you believe that people act for concrete reasons, you're interested in which of a long list of items is applicable to the people in your population. It's about filtering and not about aggregation. Extended models of behavior have been around. Howard and Sheth started this out. I saw in the early CB literature, being able to relate needs to wants, to consideration, to evaluation is something that's coming down the pike as we relate our coefficients to each other. How do I measure a need? I found great success on a 0-1 scale with a context-specific scope to it. But at the end of the day, it's about the decision variables that we have in front of us and how we relate Bayesian analysis, all of that. It's an interesting, wonderful, exciting frontier, and you can read about it by Googling 7 Summits of Marketing Research. You can download the software, you can download the book, and I hope that you do that. Thank you.